Bonjour, welcome to Paris, France, the City of Lights. We're going to be together for 8 weeks for this course on functional analysis here at Central Paris. Let me tell you how this class is going to be organized. Every week you will have video lectures, and I will be the one providing the video lectures. There will be some text to read, some PDF reading material that has been prepared by Anna Rosanova-Piera, who is an associate professor here at Central Paris. And you will also have to take some quizzes and write some proofs that will be peer graded, which means you will also have to grade some of your fellow classmates' proofs. This is important because math is not simply about answering questions in the quiz, it's also about being able to prove, to find a way to prove something, and then also to write the proof correctly. There is something which is extremely important and you need to take part in it. You need to participate in the forums. It's extremely important. Talk to your fellow classmates, interact. That's going to be a lot of fun and it's really part of the experience. Now, when it comes to passing the class, well, there will also be a final exam, and you will pass the class if you have more than 60% when you actually take the grades of, well, the peer grading material, quizzes, final exams. You can actually look at all of the coefficients on the site. It will tell you how we compute the overall grade. And if you have more than 60%, then you will pass the class, which means that you will have a certificate. And if you have more than 80%, then you will have distinction on the certificate. Now, if you only want to do the videos, you can do that. The PDF reading material is not necessary to understand the videos. I mean, we will not make references to what is in the PDF reading material. However, I strongly suggest you read the PDF material because it's really interesting and it will really give you a good grasp of what is functional analysis. Now, let me tell you what we're going to do during this first week here at Central Paris for this class on functional analysis. First, I will tell you what is the purpose of functional analysis, what to expect. Even though I believe that you have watched the trailer where I was in front of the Eiffel Tower and explained to you a few things, well, I will get into more details today. I will go down to the rugby field of Central Paris to give you more details with what is functional analysis. Then I will tell you what is a topology, and then what are open sets and closed sets, also what are compact sets. And then we will need to talk about convergence. If you took calculus, you already know about convergence a little bit. You know about the sequence 1 over n. You know that this sequence, which is 1, 1/2, 1/3, etc., you know that this sequence converges to 0 if you do calculus. Okay, but what about this sequence? What about the triangle, the square, and I mean, does this converge to a disk? Before we answer the question, does this converge to a disk, we need to answer the first question, which is, what does it mean to converge? And then we can answer the question, does it converge to a disk? So the question of the definition of convergence is a question, and we will address it. Look at this function. Look at fn of x equals absolute value of sine of x raised to power n. You can use a graphing calculator to plot it for different n's, n equal to 1, 2, 10, 1 million, and you will see that you kind of want to say that this function converges somehow to 0, but there are some points where it's not 0. You kind of want to say this, but is that true? Does it converge to this function? I don't know. Well, the question is, well, what is convergence? And maybe we can define several types of convergence. And if we define several types of convergences, then there will be some cases where it does converge and some cases where it does not. So this question about convergence needs to be addressed. So back to what we will learn this week. We will learn to define convergence. And to do this, we will use topology and open sets. That's actually why we're going to define topology and open sets to begin with. That's to be able to define convergence. Then we will define continuity, and we will see what is the initial topology. I will define this in the video, so you don't know what the initial topology is yet, but you will learn about this week. And then I will tell you how to trick your calculus instructor, because every function can be continuous. And we will also see what the topology sees and doesn't see. So I'm going to go down to the rugby field of Central Paris, and I will meet you there in a minute.